So in the previous session, this is actually 6-2, not 7-2. We talked about solving systems of equations by graphing. We talked about converting equations that are in different forms, sometimes to the same form, so it'll be easier to compare systems. When you're graphing a system, what tells you that something is a solution of that system? The point at which they intersect. Okay? There we go. So if they intersect at one point, then there is one solution. If it is the same equation, then those two lines lie on top of each other, which means there are infinite solutions. And if they have the same slope and different y-intercepts, then they are parallel, which means they have zero solutions, no solution. All right.
There can never be two solutions.
There can never be two solutions unless
It's like
you
what if it intersects at two different points?
parabola. Could there be?
yes,
Wait, what
or
if
if there are more than
Yeah.
two equations in the system.
Wait, but what if it? Yeah.
Okay. How do you know about the parabola?
We were talking about it last year.
Okay, good. I'm glad you remember that. Okay, so that has even the parabola can have no solution, one solution, or two solutions. We'll get to that later.
Like this?
No, if the parabola intercepts the x-axis, those 2 points at which the parabola intercepts the x-axis are considered to be the solutions of the equation. So sometimes if the parabola is above the x-axis, then there is no point of interception. Sometimes the graph can pass through the origin, which means the vertex, the lowest point or the highest point of the graph is at the origin or the different point, then there is one solution. But sometimes you will see the graph intercepting at 2 points on the x-axis, then there are two solutions. Okay? So let's get to this. So I have two equations here, y equals negative 4x plus 8 and y equals x plus 7. All right? I'm going to substitute y equals x plus 7 in equation 1. Do you understand why I'm doing that?
Yeah.
Because you have y equals something, correct? You have y equals something. And I'm saying, hey, y is nothing but x plus 7. So instead of y,
You can say x plus 7 equals negative 4x.
There we
so
go.
That you can solve for x. So that you will.
so I have x plus 7 equals negative 4x plus 8. Now what have I done to the equation?
Made it easier
How?
by using only one variable.
Excellent. I've changed the equation from a two-variable equation to a single variable equation. And all I need to do is, this is going back to 7th grade, where you're combining like terms and then solve for x.
You could do it the other way too, right?
I can do it the other way too.
But this was.
But you're going to get the same equation,
Yeah,
right?
do the same thing.
Yeah. So what two terms should I combine first? 7 and 8, you want to do that first? Let's see. I think I want to do the x terms first. Yeah, so I'm going to add 4x to both sides. And I have 5x plus 7 equals, these two will cancel out. And I have 5x plus 7 equals 8. Subtract 7, pardon me?
Oh, never mind. Sorry.
Okay.
I thought.
Subtract 7 from both sides. And I get 5x equals 5x equals 1, and then divide both sides by 5, and I get x equals 1/5. Right? Or 0.2. Now, why am I allowed to use either 1/5 or 0.2?
Because
because there are no fractions or decimals in the original equation, and sometimes a decimal might work better, sometimes it might be the fraction. So, but be flexible. Don't just get fixated on the decimals because somehow in your head you think decimals are easier to deal with. Not always the case.
Yeah, I think fractions.
Yeah, especially if you can cancel out. There's nothing like fractions. Michael? All right, so now remember, we are getting to the point where we need a solution. Now, do I have a solution at this point?
No.
No, I have one of the coordinates of what might be the solution. You guys see that? Because I would end up with something that looks x comma y. Now I have x, I need y. So what do?
Other way
I
around.
take this value, plug this in one of the equations. Which equation did I use?
The second one.
Yeah, use the second one. Use the simplest one.
So it's
Okay? So let's take this and plug this in here, and we have 0.2 plus 7, which is 7.2. So what is the solution of the system? 0.2 comma 7.2. Okay? All right. Now let's, just for fun, plug in 1/5 instead of 0.2.
1/2.
So I have negative 4/5 plus 8, and I'm using the other equation here. You notice that?
Yeah.
Okay. And I have 7.7 1/5 or 7.2. I can also check, maybe I should check, plug this back in the original equation and make sure that the left side equals the right side.
Is your stylus kind of like lacking? Like the lagging?
Yes, because this is not the stylus that comes with Doceri.
Really carry.
Doceri. Okay. Let's move on.
This can be an advertisement.
Y equals 2x. 7x minus y equals 15. Remember, we are still using substitution, but the form of the equation is slightly different, correct?
Yeah.
Now, in the previous set of equations, or the previous system, both were in slope-intercept form. Now you have one in slope-intercept form and the other one in standard form. Okay? But you still know what y is, and your goal is to get it to a single variable equation. So George, help me out. What should I do here?
You want
The operative word is substitution.
to substitute
Emily, do you want to help George?
Would you substitute 2x? Wait, no. Would you substitute the y and y equals 2x with 15? No, with 7x? 7x.
Izzy?
I have a question. Would it be easier if you converted to slope-intercept form?
No, don't waste your time doing that.
Well, what you would do, because if you want to substitute, you would do 7x minus 2x.
So what am I doing? Or what do you just do? I'm substituting.
Equation you're substituting.
Exactly. I'm substituting
2x.
this y with this 2x. right? I'm taking this out, I'm plugging in 2x because what does the equation 1 say? Y equals 2x. So instead of y, I can just say 2x. Can I not? Okay? So now my equation is 7x minus 2x equals 15. Are you all with me? Sure?
Yeah.
Emily, you with me? Okay. Now simplify. 7x minus 2x is 5x equals 15. Divide both sides by 5 and you get x equals 3. Okay. Now there's only half the solution. You need to plug this back in. Lucy, help me out.
Plug it back into y equals 7x minus 7 times 3.
Why? Why do you want to do that? Not that you can't, but why do you choose to use? Just you go for the simpler one, right? Because this equation is still in play. You understand? We've used that value, but the equation is still in play. So instead of plugging in x equals 3 in equation 2, you can go ahead and do it in equation 1.
So y equals 2 times 3.
Yes, which will give you 6. And so what's the solution of this system? 3 comma 6. What is the last step? To check. Now, since I used y equals 2x to plug in, where should I, which equation should I use to check?
The other one.
Just use the other one.
To make sure.
Okay, just to make sure, exactly. So I'm using 7 times 3 minus 6 should equal 15. So I have 21 minus 6 should equal 15, and 21 minus 6 is 15, which equals 15. Right? There you go.
Remember that really creepy smiley face that was like,
Yeah, with all the teeth showing.
We had like the clown one.
Yes.
Yeah, you.
Izzy.
I just want to make sure that I myself. So the solution of the system 3 comma 6 is the point of intersection.
Exactly. If you're graphing, that's what it would mean.
Okay.
Okay?
And this is to find it without graphing.
You were trying to do this without graphing.
So it's just another way to do it without graphing.
Correct. And there's also another method. We'll talk about this next. Okay. Okay, 2 equations, both in standard form. How do you use substitution? Buddy.
Would you switch one of them to slope-intercept form?
Okay, so you want to change one of them to slope-intercept form. And do you have a preference?
The second one because it's positive.
The second one, because I can do it in one movement, right? With one change, I can do that. You understand what I'm saying? Because the first one, the y has a coefficient of 3, whereas here, y only has a coefficient of 1. Okay? So if I move the negative 6 over to the other side by adding negative 6x, by adding 6x to both sides, then I can I can convert that to slope-intercept form. Okay? Now am I ready to plug in?
Well, we define.
Oh, I just have a question.
Yes.
Why do you convert it slope intercept form?
Because I'm trying to substitute. Okay?
Why didn't you do it if they're in the same form?
How will you, what are you substituting for?
Right, okay. That makes
You understand? There's no y equals. You need a value for y.
okay.
Now, when we do the next method, which is solving by elimination, then you don't have to convert this to slope-intercept form. Okay, we'll talk about that later. Jimmy, you're looking forward to that, huh? No, you should be.
But I was going to say, for elimination, would you rather it be instead?
Yes.
Wait,
Yes.
So like subtracting?
so,
Correct. You can add or subtract.
so now would you do 6 parentheses like 3y plus 2x? Or would you find the x and y value?
So since I changed the second equation, I'm going to change this. I'm going to plug this in the first equation. Okay?
Because you have the value for y for the first equation.
Correct. Okay? And you know that y equals 6x minus 7. So when you plug that in, the first equation is going to be 3 times quantity 6x minus 7 plus 2x equals 4. So we're back to distributive property, which we learned in chapter 3. Okay, that's going to come back, and that's why we needed to master it back then. Now, this is not a very complex distributive step. So you're going to distribute the 3 to the 6x,
18x
and you
minus
get
21.
18x minus 21 plus 2x equals 4. Now combine the like terms, 18x and 2x, which will give you 20x minus 21 equals 4. Add 21 to both sides, and you get 20x equals 25. Divide everything by 20, and you get x equals 1 and 1/4.
Oh, okay. Oh, I almost got that. It just as Michael did.
Okay? Alright, so we have part of the solution. Let's take this and plug this back in.
Wait, it's 1 and 1/5.
5/20ths.
It's 5 over 20, which
It's
is 1/4.
1 and 5/20ths, right? Which will be 1/4. That's okay.
It would be like 2.5 over 2, but then half of 2.5 over
Alright, so let's plug this in the second equation. Now, I'm using the modified form here. Is it okay to do that?
yes.
Right? I can do that. I can use this, or I can... Now, why should I not plug this in the original form?
Because that's the form. Oh,
Wait, why would you use the model?
It's already simplified,
Yeah.
right? If you were to plug the value of x in equation 2, you still have to simplify and solve for y. Now, you already have the simplified form, so why don't you just use that? Jimmy?
You could, but if you made a mistake and you were simplifying it, then your answer would be wrong.
That's a good point.
Would already be.
Yeah.
So, then what did it was over here.
Okay.
And how
Yeah, but at that point, whether if your x value is going to be wrong, okay? So yeah, so there's I don't know if you can detect if you've made a mistake. Okay, you're just going to move along thinking that you did the right thing. So just be careful when you convert to slope-intercept form and then plug in. All right. So y equals 6 times 1.25 minus 7. What is 6 times 1.25?
7.5.
Yeah, you're right.
Whoa!
7.5 minus 7 is
0.5.
0.5. So your solution is
Y equals 0.5.
1.25.
Zoe. What's the solution?
Y equals 0.5.
And that's the solution?
No,
Okay.
that's the Y solution.
Okay.
The solution.
So what is the solution of the system?
The solution of the system is
Look, okay. See, that's what happens when you get distracted even momentarily.
But it was
I have
over
X here, I have Y here. Let's put them both together.
So it's 0.5 equals
No,
6
X value comes first. So it's going to be 1.25 comma 0.5. You're doing so well up until just that point, okay? Stay focused. Don't turn around and look at Lucy Brewster.
She was doing that.
Okay.
excited.
All right. Okay. Okay, so let me read out this problem to you. This is from the previous textbook. All right. Okay, page 384, problem 22.
I missed the old textbook.
You missed the old textbook?
I like this one better.
I like the font on this one better.
Okay.
The font is the same.
Okay, thank you. I'll pass information on to Pearson. All right. A farmer grows only sunflowers and flax on his 240-acre farm. This year he wants to plant 80 more acres of sunflowers than of flax. How many acres of each crop does the farmer need to plant? All right. So what is the total acreage? 240. Okay, let me just write those things up here.
Wait,
So
Father, are flags like a type of like flower or
It's a flax seed.
yes. Again, does it matter?
No, but I was just wondering.
No, yeah, you. Okay. So the total acreage is 240 acres. Come on. Okay. This year he wants to plant 80 more acres of sunflowers than of flax. Okay. So which is going to be more? Sunflower is going to be more by 80 compared to flax, but you only have 240 acres to work with. Okay. So tell me, what are the two variables here?
Flax and sunflower.
Okay, sunflower number, the number of acres that the sunflower crops are going to be, and the number of acres where the flax are going to be planted. Okay.
So would you write this in standard form?
Okay. Now remember, you're writing a system here.
But could you originally write it in standard form and then convert it
It's up to you.
if you were?
So let the number of acres with sunflowers be S, and let the number of acres with flax be F. Okay? Now there are two situations that are built into this problem. What are the two situations?
That.
The acres with sunflowers.
Sunflower.
Okay, and you know that the sunflower, whatever the number of acres.
It's 80 more.
It's 80 more
than
the
the
number of flags.
Okay, let's start with the 240. What is the 240? Total number of acres, and that includes what? Sunflower S and F, right? Okay, so
S plus.
my first equation is going to be S plus F equals 240. Do you see that? Okay. All right. So we've established that. Now let's look at what he wants to do this year. He wants to plant 80 more acres of sunflowers compared to flax. How do you write that as an equation? Emily?
S equals F plus 80.
S equals F plus 80. Excellent. Right? Do you have a system now? Okay. Is it in a form where you can readily substitute? Yes? What did you say? 2f?
2f plus, well, you will get f plus
She
8
simplified.
Oh, you're plugging in already. All right, so I'm going to, instead of s, I'm going to substitute f plus 80.